In this videotape, we're going to begin an elementary algebra final review. Okay, this is part 1. And we're going to be going over examples, the type of which you might see on a final exam. Okay, the first example, I want to evaluate -7 minus 3 times 2 minus 7, parentheses there, minus a minus 4. Okay? Now we have to remember order of operations here. We're not just going to jump right in and say -7 minus 3 is minus 10 and try to multiply that by the minus 5. Instead, we realize that multiplications and division should be performed before additions and subtractions, so that this multiplication, okay, 3 times what's in here, is going to come before this subtraction. So we have -7 minus 3. Now 2 minus 7 leaves us minus 5. Minus a minus 4 is like plus 4. Okay, you're adding a plus 4. Okay, once again, this multiplication will come first. So -7 minus 3 times minus 5 is plus 15 plus 4. Okay, 19 minus 7 for a final answer of 12. In the second example, we want to evaluate the following. -4 times, in brackets, 8 minus 3 times 2 minus 6 in parentheses over -5 minus 7 times minus 5. All right, now, as I said, multiplications and divisions will precede additions and subtractions, except, okay, when grouping symbols come first. Grouping symbols can change the order around. So although we do multiplications before we do additions and subtractions, since we have this 2 minus 6 inside the grouping symbol, we will handle that first. So first we take care of the stuff that's in the grouping symbols. So let's see what we have. -4. We don't make 8 minus 3 5. We leave it 8 minus 3 times minus 4 over -5. Now, -7 times minus 5 is plus 35. Notice we did not make it minus 12. The multiplication comes first. -4 times 8 minus 3 times minus 4 is plus 12 over -5 plus 35 gives us 30. So we have -4 times 20 over 30 minus 80 over 30. And of course we can divide numerator and denominator by 10, leaving us with minus 8/3. Now, third example, if x equals -5 and y equals 3, evaluate x plus y cubed minus xy squared minus the absolute value of x minus y. Okay, let's see what we get. X plus y cubed. That's -5 plus y plus 3 cubed. Take away x times y squared. X is -5, y is 3. Take away x minus y minus 5 minus 3. Minus 5 plus 3, that's minus 2 cubed, minus 5 times 3 squared, which is 9. Take away now the absolute value of minus 8. Minus 2 cubed, minus 2 times minus 2 times minus 2, the result is minus 8. Now, minus 5 times 9 is minus 45, so take away minus 45. Take away. Now, the absolute value of minus 8 is plus 8. So we have minus 8. When you're subtracting a minus 45, that's like adding a plus 45. And here, take away 8. So we get 45 minus 16 for a final answer of 29. Okay, on this problem, just want to mention over here when we had the minus 5 times a 3 squared. Okay, just the 3 was being squared to give us 9. It was minus 5 times 9, minus 45. You don't make it minus 5 times 3 minus 15 and square that. It's only the y that's being squared, not the product. Okay, in our fourth example, we'd like to simplify the following expression. 2x squared times minus 3xy times 2y minus, in parentheses, 4x squared minus 3x cubed y squared. Okay, now you hear so much about the distributive law. Some people want to use it even when it's not applicable. Okay, you don't say 2x squared times the minus 3xy and then the 2x squared times the 2y. Or looking at it the other way, you don't think of this. If it had been 2x squared minus 3xy times 2y, then you would have needed the distributive law. It would have been the 2x squared times the 2y minus the 3xy times the 2y, like a plus b times c. But that's not what we have here. Okay, this parentheses makes a big difference in the problem. All we're doing is multiplying this times that. Okay, so we can say first, take care of the first two factors. We'll have here minus 6x cubed y minus 6x cubed y times 2y. Take away. Now here we certainly do need a distributive law. It's like minus 1 being distributed through the parentheses. Minus 4x squared minus 1 times minus 3 plus 3x cubed y squared. And now, multiplying this by this, we get minus 12x cubed y squared minus 4x squared plus 3x cubed y squared. Okay. Minus 12x cubed y squared and plus 3x cubed y squared. These are like terms. Okay, and that gives us, we can combine them. Minus 12 plus 3 combines for minus 9 x cubed y squared minus 4x squared. Okay, in our next example, we want to simplify the following. A plus b, in parentheses, squared, plus a minus b, in parentheses, squared. Okay. Now you don't think of this as just a squared plus b squared. We know that a plus b squared means a plus b times a plus b, and doing that by FOIL gives you a squared plus 2ab plus b squared. That is, it's a plus b times a plus b. And here we're going to have a minus b times a minus b. So by FOIL, we have a squared plus ab for the plus 2ab plus b squared. And here, similarly, by FOIL, a squared, first, outer and inner, minus ab minus 2ab plus b squared. So the 2ab and the minus 2ab cancel each other out. We have a squared plus a squared, 2a squared, b squared plus b squared plus 2b squared. In example 6, we want to multiply and simplify 2x minus 3 times x squared plus x plus 3 plus x minus 3 squared. Okay, by the distributive law, we can think of this as a plus b times c. That is, a times c plus b times c. Or 2x times x squared plus x plus 3 minus 3 times x squared plus x plus 3. 2x times this minus 3 times that. Plus, this is really x minus 3 times x minus 3. Okay, now let's use the distributive law again. 2x to be sent through the parentheses here. 2x times x squared, 2x cubed. 2x times x is 2x squared. 2x times 3, that's 6x. Now minus 3 times x squared, minus 3 times x, minus 3 times 3. Plus, using FOIL, x squared minus 3x minus 3x minus 6x plus 9. And now let's try to combine like terms. Okay, this is the only term involving x cubed, so we'll just be leaving that. Now let's look at the terms involving x squared. We have a 2x squared, a minus 3x squared, and a plus x squared. 2x squared minus 3x squared, that's minus x squared, plus x squared is 0x squared. So the x squareds drop out. Now let's look at the x terms. We have plus 6x minus 3x minus 6x. So we have 3x minus 6x for minus 3x. And then finally, the constant terms, the minus 9 and the plus 9 cancel each other out. So we're just left with 2x cubed minus 3x. Okay, in the next example, we want to use long division x cubed plus 4x minus 5 divided by x minus 1. Okay, this means x minus 1 goes into x cubed plus 4x minus 5. We want to make sure to write these terms in descending order and to leave place for every term. If we have an x cubed, and this is an x to the first power, let's put in a 0x squared as a placeholder so that everything will line up nicely. Then we say to ourselves, how many times does x go into x cubed? X into x cubed goes x squared times. X squared times x gives us x cubed. X squared times minus 1, minus 1x squared. Now we subtract, okay? That means to change the signs and to add. This, of course, originally was plus, so we change it to minus. Here we change it to plus, and we add. The x cubes cancel. 0x squared plus 1x squared leaves us with 1x squared. We bring down the next term, the plus 4x. Now we say, how many times does x go into x squared? It goes x times. X times x gives us x squared. X times minus 1 gives us minus 1x. We subtract. That means we change the signs and add. The x squareds cancel. This gives us 5x, and we bring down the minus 5. Now, how many times does x go into 5x? It goes 5 times. 5 times x is 5x. 5 times minus 1, minus 5. And finally, when we subtract, change the signs and add, of course, we get 0. So our final answer here is x squared plus x plus 5. And this could be checked by taking x squared plus x plus 5 times x minus 1 and getting x cubed plus 4x minus 5. Okay, in the following examples, in problems 8 through 11, we want to factor as completely as possible. In problem 8, it's 8x squared y squared z minus 6x cubed y z cubed minus 2x squared y z. Okay, in all factoring problems, the first thing to look for is the greatest common factor, something that we could pull out from all the terms out in front. Looking at the constants between the 8, the 6, and the 2, the most we could pull out is a 2. Looking at x squared, x cubed, and x squared, we can pull out the x squared. It appears in every term. Looking at y squared, y, and y, the most we could pull out is y. Finally, z, z cubed, and z, the most we could pull out is z. And we look to see what's left in each term. Okay, to get this, having taken this out, we'd need a 4 to get the 8. X squared is okay. We need a y to get the y squared. So just 4y. Minus, now, to go from 2 to 6, we'd have to multiply by 3. To go from x squared to x cubed, we'd have to multiply by x. Y is all right. Z has to be multiplied by z squared. Minus, and we have here exactly what we have there. So everything has been taken out. 2x squared y and z. And this, of course, can be checked by actually multiplying back. And this is as far as we can go in this problem. Okay, in problem 9, x squared minus 3x minus 40. There is no common factor other than one that we can pull out. Here we have a second degree, and we're going to try to write this as a trinomial. We're going to try to write it as a product of two binomials. And we're looking for two numbers which multiply to minus 40 and add to minus 3. And that you can do in your head. They are minus 8 and plus 5. Now let's check this by FOIL. X squared plus 5x minus 8x is minus 3x, and then minus 40. In problem 10, 8x squared minus 44x plus 60. First, we look for a common factor. Even though it's a trinomial, we still start by looking for a common factor that we can pull out. And we see that we can pull out a 4, leaving us with 2x squared minus 11x plus 15. we're now going to try to write this as the product of two binomials. As since the only way to make the 2x squared would be the 2x and the x. We have to now look at the various ways we could make the plus 15. And you can sort of list them in a table. It could be 15 times 1, or 5 times 3, or 1 times 15, or 3 times 5. This is to cover you. In other words, it could have been x here and 2x here, so this covers all the possibilities. And in this case, since we want the product to be plus 15, okay, we're multiplying to plus 15, the signs here are going to be the same, either two positives or two negatives. Now, whether they're two positives or two negatives, when you do FOIL, they'll have the outer and the inner will have the same sign, so essentially it'll be an addition table. So what I'm going to do here is multiply 2 times 1, 15 times 1, and add. Do I get an 11? 11 or a minus 11? Okay, we can take care of the minus sign later. Okay, basically what we're going to need is the two minus signs to get the minus 11. Right now I'm just looking for an 11. And here on the second one we get it, 2 times 3 and 5 times 1. This gives me 6 plus 5, 11. That is, the 2 should be multiplying the 3 and the 5 should be multiplying the 1. Since 2 is on the outside here, I'm going to have to put the 3 on the outside here and the 5 on the inside. So now with the FOIL, I will have the 6x and the 5x. Now I want minus 11x. So they're both going to be minuses. This gives me 2x squared minus 6x minus 5x minus 11x plus 15. And here is our final answer. Okay, in 11 we have 3x cubed minus 48x. Once again, looking for the common factor, we see we can take a 3x out in front. That leaves us with x squared minus 16. However, x squared minus 16 can now be factored further. It's the difference of two squares, and we can, just like a squared minus b squared, we can write it as a plus b times a minus b. Or if you want, you can look for, you want to write this as a product of two binomials, and you're looking for two numbers which multiply to minus 16 and add to 0, because there's a 0x here, and of course they're plus 4 and minus 4. And you can check it by a FOIL. So our final answer in this case is that. In problem 12, we want to reduce to lowest terms 2x squared plus 6x over x squared plus 6x plus 9. Okay, now of course you cannot just cancel the 6x's here. 6x is not a factor in the numerator and denominator. It's a term in the numerator and the denominator. What you must do, of course, first is to factor completely the numerator and the denominator, and then try to cancel those factors that are in common in top and bottom. Now factoring the numerator separately, we say, well, what can we pull out? The greatest common factor would be 2x, leaving us with x plus 3. And in the denominator, we have x squared plus 6x plus 9. There is no common factor other than 1. But we can say I'm looking for two numbers which multiply to plus 9 and add to plus 6. And they are, of course, plus 3 and plus 3. At this point, we see that x plus 3 is a factor in common top and the bottom. We can divide top and bottom by x plus 3, giving us a final answer of 2x over x plus 3, which is as far as we can go. We cannot cancel the x's. X is a factor upstairs, but only a term downstairs. And that's the answer in this example. the following examples in 13 to 18, we want to perform the indicated operations and simplify. And in 13, we have the following. X squared minus 4 over 4x squared times 2x squared plus 4x over x squared plus 4x plus 4. All right. To multiply two fractions, we can multiply the numerators and put it over the product of the denominators, but it's helpful first to try to reduce to lowest terms if possible. We're going to factor every portion here separately and see if we can cancel anything out. X squared minus 4 factors, of course, into x plus 2 times x minus 2. It's a difference of two squares. 4x squared, if you want to, you can say it's 2 times x times x. Or you could just leave it 4x squared. Here, 2x squared plus 4x, a common factor would be 2x, and you would be left with x plus 2. And x squared plus 4x plus 4, you're looking for two numbers. There is no common factor other than 1, so you're going to try to write it as the product of two binomials. You're looking for two numbers which multiply to 4 and add to 4, and they are 2 and 2. And now let's see what we have. X plus 2 is a factor, top and bottom we can cancel. X plus 2 again over here. The 2x cancels the 2x here, leaving us with x minus 2 upstairs and 2x downstairs. And that's as far as you can go. 2 is a term here, a factor here, x is a term here and a factor here, so you cannot cancel them. In problem 14, it's x squared plus 8x plus 16 over x squared plus 6x plus 8 times x squared plus 3x plus 2 over x squared minus 16. Once again, we're going to try to factor each numerator and denominator as far as we can, and then to see if any factors can be canceled out. Upstairs there are no factors, common factors other than 1, so we try to write it as a product of two binomials. We're looking for two numbers which multiply to plus 16 and add to plus 8, and they would be 4 and 4, x squared plus 8x plus 16. Downstairs, also no common factor other than 1. So we look to find two numbers which multiply to plus 8 and add to plus 6. Plus 4 and plus 2 will do it. Here also, top and bottom. There are no common factors other than 1. On top, two numbers which multiply to plus 2 and add to plus 3. They're plus 2 and plus 1. And downstairs, two numbers which multiply to minus 16 and add to 0. And they are plus 4 and minus 4. Or you see this is the difference of two squares, so it's a plus b times a minus b directly. Okay, this is a plus. Okay, x plus 4. You can divide numerator and denominator, cancel those x plus 4s. You could also, over here, cancel this x plus 4 with this one. And this x plus 2 with that, leaving us with a final answer of x plus 1 over x minus 4. In 15, we have the following: 6x cubed y squared over 5z to the 4th divided by 15x squared y. All right. Well, it's like dividing by this over 1. And we know that what we can do is invert and multiply. So this is 6x cubed y squared over 5z to the 4th. Instead of dividing by this fraction, we can multiply by the reciprocal, 1 over 15x squared y. Okay, remember that. Even though it's just 15x squared y, you think of it as that over 1, and then when you take the reciprocal, it's 1 over 15x squared y. All right, let's see what we can do. We can divide numerator and denominator by x squared. Here it'll go out. Here, x cubed divided by x squared will leave us with just x. Then we can divide numerator and denominator by y. It'll go out here. Y squared divided by y will leave us with y. Okay, now as far as the 6 and the 15 goes, we can divide numerator and denominator by 3. 15 divided by 3 would leave us with 5, and 6 divided by 3 would leave us with 2. That seems to be the best we can do. What are we left with? On top, 2 times x times y times 1, 2xy. And downstairs, 5z to the 4th times 5, or 25z to the 4th, which is in lowest terms. In problem 16, we have the following: x squared y plus xy squared over x squared plus 2xy plus y squared divided by x squared y squared over x plus y. So what we have here, before we try to factor or anything, let's just change our division to a multiplication. Instead of dividing by this fraction, we will multiply by the reciprocal. Okay, now we'll try to factor. On the upper left here, we see that the common factor is x times y, leaving us with x plus y. You check this by multiplying x squared y plus xy squared. Downstairs, there is no common factor. Instead, we write this as x plus y times x plus y. Think of looking for two numbers which multiply to y squared and add to the 2y, following what we used to do. So, and they add to the 2xy here when you do it. So it's x squared plus xy for the plus 2xy plus y squared. And over here, x plus y, and x squared y squared. You could think of it as xy times xy. I just wrote it that way because I see that xy is a factor there. Otherwise, you could have left it x squared y squared. Okay, x plus y cancel there and there. X plus y cancels there and there. xy cancels there and there. Now, what have we been doing when we're canceling? We're really dividing top and bottom, say, by xy. Okay, so if the result is just 1, we leave it alone. We usually don't write anything. Okay, but you have to be careful. I don't want you to say, well, there's nothing up here, and put a 0. You realize that in each of these, when you divided by xy, you were left with 1. So you're left with 1 times 1 times 1, or 1 over xy, not 0 over xy. All right, in example 17. We move on to addition and subtraction of fractions. We have 5 over 6xy minus 4 over y squared plus 3 over 4x cubed. Now we know in order to add fractions or subtract fractions, they have to have the same denominator. So what we're interested in doing is building fractions equivalent to each of these, each having the same denominator. Now, what denominator? We look for the lowest common denominator, the smallest quantity that has each of these denominators as a factor. Okay, and the way to do that is to look at, to find the lowest common denominator. We look at each denominator separately, and we factor it completely. This is 6xy is 2 times 3xy. This is y times y. 4 is 2 times 2 times x times x times x. Factoring everything completely, and the constants, writing them in terms of their prime factors. Then we take each factor, the largest number of times it appears in any one denominator. Okay, so you say 2 appears twice here, no times here, once here. So we take 2 twice. We don't take it 3 times. You don't add up the total number of appearances. Okay, we just take the largest number of times it appears in any one denominator. 3 appears once, 0, 0, so we take it once. X appears once, 0, 3 times, so we'll take it 3 times. Y appears once, twice, 0 times, so we'll take it twice. Giving us, as our LCD here, 4 times 3, 12, x cubed, y squared. That is, we're going to try to build fractions equivalent to each of these, having the common denominator 12x cubed, y squared. And we know that we can do that since each of these denominators is a factor of 12x cubed, y squared. Now we're going to use the fundamental principle of fractions, which says that if you take a fraction, if you multiply the numerator and the denominator by the same non-zero quantity, you'll get an equivalent fraction. Okay, so we ask ourselves, what did we do to this denominator to get that one? What did we multiply this denominator by to get this one? And we have to multiply the numerator by the same quantity to get an equivalent fraction. So in each case, we're going to multiply the numerator by whatever it was that we multiplied the denominator. Okay, to go from 6 to 12, we had to multiply by 2. To go from x to x cubed, we had to multiply by x squared. To go from y to y squared, we had to multiply by y. Since we multiplied the denominator by 2x squared y, we have to multiply the numerator by that as well. Now we look over here and we say, what did we do to this denominator to get that one? And we see that we had to multiply this denominator by 12x cubed, so we multiply the numerator by that as well. And then finally, what did we multiply this denominator by to get that? To go from 4 to 12, we multiplied by 3. From x cubed to x cubed, we left it alone, and then we had to multiply by y squared. Okay, we are now trying to add and subtract fractions, all having the same denominator. It's this minus this plus this. Since they have the same denominator, you can combine numerators and put them over the same denominator, and we get here 10x squared y minus 48x cubed plus 9y squared. And there we have it. And there are no common factors here. This is in its lowest terms. Okay, problem 18. 4 over x squared minus 2x plus 3 over x squared. Once again, we would like to add fractions. We have to determine first the LCD. We realize that this is x times x minus 2 if we factor it completely. So the LCD, take each factor the greatest number of times it appears in any one denominator. X appears once here, twice here, so we need it twice. X minus 2 appears once here, no times here, so we need it once. So the LCD is x squared times x minus 2. So we're going to build fractions equivalent to this. Okay? Equivalent to these, each having denominator x squared times x minus 2. In each case, we ask ourselves, what did we do to the denominator to get this denominator? We multiply the numerator by the same quantity. Okay, to go from x times x minus 2 to x squared times x minus 2, we obviously multiplied by x, so we have to multiply the numerator by x as well. To go from x squared to x squared times x minus 2, we had to multiply by x minus 2, so we have to multiply the numerator by x minus 2 also. Now we have two fractions with the same denominator, so we can combine the numerators over that denominator. 4x plus 3 times x minus 2. This gives us 4x plus 3x minus 6. Don't forget to distribute the 3 through the parentheses. Over x squared times x minus 2. 4x plus 3x, that's 7x minus 6 over x squared times x minus 2. And that is already in lowest terms. It can't be reduced. You can leave your answer in this form. If you want to multiply through, distribute the x squared, you can either way. All right, in example 19, we want to evaluate the following. 4 times 3 to the 0 plus 6 to the minus 1 plus 3 to the minus 2. All right, this is not 4 times 3, 12 to the 0, which would be 1. This is 4 times 3 to the 0. 3 to the 0 is 1, plus 1 over 6 to the first power, plus 1 over 3 to the second power. Okay, we move these things to the denominator with positive exponents. And it's just 3 that is being raised to the 0 power, not 12. So we have 4 plus 1/6 plus 1/9. We would like to combine this into one fraction. The LCD would be 18. Okay, so we're trying to build fractions equivalent to the original ones here, all having denominator 18. This has denominator 1. So if we multiply the denominator by 18, we have to multiply the numerator by 18 as well. Here we multiply the denominator by 3, so we have to multiply the numerator by 3. Here we multiply the denominator by 2, we have to multiply the numerator by 2. That gives us 4, okay, well we can combine everything over the same denominator, 18. 4 times 18, that's 72, plus 3 plus 2, for a total of 77 over 18. And that's as far as we go. Number 20, we want to simplify. The following, we have 2x squared cubed y to the 4th over xy to the minus 2, all raised to the second power. All right. This gives us, now 2x squared cubed means 2 gets cubed and x squared gets cubed, y to the 4th. And here, this product squared means x gets squared and y to the minus 2 gets squared. Okay. 2 cubed, that's 8. X squared cubed, you multiply the powers, you get x to the 6th power, y to the 4th, over x squared, y to the minus 2 to the 2. You multiply the powers, you get y to the minus 4. Okay. Now you can break this up into, say, 3 problems. 8 times x to the 6th over x squared. When you're dividing and they have the same base, you can keep the base and subtract the powers. And here, when you're dividing same base, you keep the base, you subtract the powers. 4 minus a minus 4 gives us 8 x to the 4th y to the 4 minus a minus 4 y to the 8th power. All right, in our next example, all right, in 21 we want to simplify following. The square root of 100 minus 36 times the square root of 5 to the 4th power. Okay, first of all, this is not the square root of 100 minus the square root of 36. You can't break it up. You can break up products or quotients, but not sums and differences. You have to just say 100 minus 36 is 64. Okay, the square root of 64 is going to come out to be 8. If you tried to break it up separately, the square root of 100 minus the square root of 36, you would have gotten 10 minus 6, or 4, which is not the right answer. Now the square root of 5 to the 4th power means the square root of 5 times the square root of 5 times the square root of 5 times the square root of 5. The square root of 64 is, of course, 8. The square root of 5 times the square root of 5 gives you 5. And again, the square root of 5 times the square root of 5 gives us 5. 8 times 5, that's 40 times 5 for a final answer of 200. In 22, we want to simplify the following. The square root of 27 plus 3 times the square root of 48 minus 2 times the square root of 75. Okay, in order to combine radicals, in this case, we first have to put each radical into simplest radical form. Okay, so we're going to look to pull out the perfect squares in each instance. Well, you can think of this 27 as 9 times 3, where 9 is a perfect square. And 48 can be written as 16 times 3, where 16 is a perfect square. And 75 as 25 times 3. In each case, we have pulled out the perfect square factors. We can then say this is the square root of 9 times the square root of 3, the square root of 9 times 3, the square root of 9 times the square root of 3, plus 3 times the square root of 16 times the square root of 3, minus 2 times the square root of 25 times the square root of 3. This gives us the square root of 9, which is 3 the square root of 3, plus, now the square root of 16, that's 4. 3 times 4, that's 12 the square root of 3. The square root of 25, that's 5, so minus 2 times 5 minus 10 the square root of 3, giving us, now we can combine the radicals, 3 plus 12, 15 minus 10 for 5 the square root of 3. In problem 23, we want to simplify the following. The square root of 12 x to the 7th, z to the 9th, plus xz to the 0. All right. Once again, to put this in simplest radical form, we're going to look for the largest perfect square factor. For 12, that would be 4. For x to the 7th, it would be x to the 6th. For z to the 9th, it would be z to the 8th. The highest even power contained in there. That leaves us with 3xz to get 12x to the 7th, z to the 9th, plus now xz to the 0. This to the 0 power is just going to be 1. It's going to be the square root of 4x to the 6th, z to the 8th, times the square root of 3xz plus 1. Make sure you can see that. Now, the square root of 4 is 2. The square root of x to the 6th is x cubed. The square root of z to the 8th is z to the 4th. The check, of course, is that if you were to multiply this by itself, you would get 4x to the 6th, z to the 8th. I took the square root of 4, and then I halved the powers. The square root of 3xz plus 1. Okay, in example number 24, we want to simplify the following. The square root of 2 plus the square root of 8 plus the square root of 18 all over the square root of 2. Okay, we're going to write everything in simplest radical form and see what we get. This is the square root of 2. That's already in simplest radical form. The square root of 8 is the square root of 4 times 2. The square root of 18 is the square root of 9 times 2. That gives us, now, so square root of, can rewrite this as the square root of 4 times the square root of 2, and this one the square root of 9 times the square root of 2. The square root of 4 times the square root of 2 will be 2 times the square root of 2. The square root of 9 times the square root of 2 will be 3 times the square root of 2 over the square root of 2. So we have 1 the square root of 2 plus 2 the square root of 2 plus 3 the square root of 2 for a total of 6 the square root of 2 upstairs, dividing by the square root of 2 downstairs for a final answer of 6. And you can see that the square root of 2 cancel out. And the last problem on this tape is the following. Problem 25. We want to rationalize the denominator and simplify 6a squared b squared over the square root of ab. To rationalize the denominator here, we will multiply the numerator and denominator by the square root of ab. We are multiplying by 1. Okay, that is permissible. That gives us 6a squared b squared times the square root of ab upstairs over the square root of ab times the square root of ab, or just ab downstairs. Okay, dividing numerator and denominator by a, we're left with a upstairs. Dividing numerator and denominator by b, we're left with b upstairs. Final answer of 6ab times the square root of ab. And that brings us to the end of this tape.